go! Going that way, going that way!
Parachute deployed. Catch it, Jonah.
No.
Hello everyone, and welcome to part 2 of the 2-stage water rocket project video series. Today we'll be going through some of the staging mechanism components, pressure vessel parts, and the first stage water rocket launcher. Okay, let's get into it. Okay, so let's start out with the staging mechanism. As you can see, I've now added a hose clamp which holds these springs on here with 2 wire loops to attach them on, and I've also solvent welded the first part onto the second part, so now it's a very rigid single part. And right here you can see the little release mechanism. So this hole will have a wire attached which will attach to the servo horn, and when the servo pulls it'll release, and then the second stage will fly out. So that works quite well, and you can just reset it by pushing that up and closing that in place. And then if you need to remove this entirely, you can just unhook these springs, and then this whole mechanism just unscrews because only this red part here is glued in, and so it can still unthread like normal. And I still haven't had time to glue this in, just in case I need to service anything in here. I'll do that a bit later on. So here I have the piece of vinyl tubing that I mentioned before, and it now has a metal pen lid because it is slightly larger, and in the pen lid there is a small ball bearing which can move back and forth. You can hear it rattling. And there's a little piece of wire here which prevents it from coming back out, and this acts as a very cheap and simple non-return valve, because when pressure is high on this side it pushes against the ball bearing, which stops any air from coming back out, or water, but when the pressure is higher on this side it forces the ball bearing out the way, which allows air to go around it so it can go into the pressure chamber for the second stage. And so that will just mount in here, so you just thread the tubing through and it can come out. You just thread it through like that, and then because this vinyl tubing is slightly flexible, as the air pressure pushes it down it should cause it to seal, and if not I can just put a bit of epoxy around it to make it even more airtight. So that is what's happened with the stager so far. Okay, so here we are about to glue some of these spliced bottle segments together. Here's one which is already glued, and you can see here the splice joint is just filled with some epoxy, and that firstly makes it airtight, and secondly means that under pressure it won't pull apart. So this is a very strong joint, and this will hold at least 120 psi. That's what we've tested it up to so far, but hopefully it should be able to withstand a higher pressure than that. And here is a segment which is unglued, so it just pulls apart, and as we mentioned in the last video, this section is just shrunk in some hot water which is just heated up with a frying pan, and then it just fits into the other bottle, and the glue just goes on either side, and then when they're glued together that's essentially turns it into that. And this blue tape on here is essentially some masking tape which prevents the glue from sticking to the bottle if it oozes out the gap, if there's some excess glue that comes out. The bottles that we use are these 2-litre lemonade bottles. These cost about 40 pence each and are pretty strong. They can hold quite a large amount of pressure. We have 12 of them altogether here if you include the ones which have already been cut, and we've actually been saving up for a few months and have friends who give us bottles, so it's not like we're really unhealthy and drink loads of lemonade. But if we need to make large water rockets then we do need quite a few bottles, and this should hopefully be enough to make most of the rocket. So the first stage of the rocket will require 2 of these splices, giving us around 7 litres of capacity, And the second stage will also use one of these, but we'll use a slightly smaller version in order to give it a lower capacity, but also allow for some foam to build up in there. And I'll go into that a bit later on in the series. So here we are a bit closer, and this is the epoxy. This is some 24-hour Owldite, and this is also a very simple piece which we've made. It's just a piece of scrap wood with 2 bottle caps hot melt glued on, and that just means that as we're gluing it, we can just screw each section on and we don't get glue all over the piece of newspaper here. So I'm just using a piece of scrap collar flute, which is the same material we use to make the fins and things, and just a piece of plastic to stir it. So now I'm just going to mix up some epoxy. So right here I have the first stage release mechanism for the nozzle. It includes the nozzle seat here, the locking lever, the secondary lever which locks this lever in place, and the servo motor. It also has an adapter in order to plug it into a regular hose in order to supply the air. This launcher design is based off the Air Command Rocket's Polaron G2 rocket launcher. However, theirs is made of aluminium, whereas this one is made of 3D printed parts. The way it works is you take one of these custom-made nozzles, put it onto the nozzle seat, and then lock the primary lever up like this. Then you slide the secondary lever across, which locks this in place and locks the nozzle in place. You would then connect the hose here and pressurize it, and then when you want to launch, a little Arduino will activate this servo, which will attach onto here, and then cause it to release the nozzle and cause the rocket to fly away. The release head has 2 seals on. One is an O-ring up here, which seals against the inner surface of the nozzle, and then the other one is just a flat washer, which seals against the bottom of the nozzle. This dual seal design is a redundancy system which ensures that the rocket doesn't leak while on the pad. The nozzle is 16mm in diameter, which is a lot larger than the 9mm nozzle for the second stage. The reason for this is because the larger nozzle has a greater thrust, which is required for the first stage, as it has to lift the entire second stage weight, which will weigh around 400 to 450 grams when finished. This end is 3D printed and then is inserted into a cap from a washing detergent, as it has a longer thread on the inside. This was done as I didn't really want to have to try and 3D print the threaded section, as it would be quite hard to design accurately. So instead I just made this part and then inserted it in here and secured it with a little bit of epoxy resin. The entire mechanism is mounted on a scrap piece of plastic, which will eventually be mounted on a very thin sheet of aluminium or plastic, which will slide onto the launcher, allowing it to be removable and being able to be replaced with other release head mechanisms. Keep in mind that this isn't the final launcher, and it's just the release head. The final launcher will have a guide rail and support legs to ensure that the rocket doesn't fall over, as it will be almost 3 meters tall. So here I have the parts which make up the booster or first stage fin assembly. We have 2 of these, which are some 3D printed fin brackets. These are printed in 3 parts which are completely identical and fit together and screw together similar to a hose clamp, which attaches them together. In between each part, one of these collar flute fins attaches, and these collar flute fins have holes and notches for these 2 clamps. There are 2 of them in order to keep the fins aligned across the entire rocket. There are 3 of these fins, and they're as identical as I can cut with a knife. So I'll just go and assemble those and then show you what the final product looks like. Here are the two finished fin sections. This one is for the second stage and this one is for the first stage. As I mentioned before, they use these 3D printed fin brackets which can be tightened in order to fix them to the rocket securely. And another advantage is each fin can be individually removed if it gets damaged on landing without replacing the entire fin can. This also means that it's a very modular design which allows for them to be used on many different sizes of rockets. Last time I showed you the internal mechanism for the parachute deployment mechanism, and now I have it mounted inside the aeroshell. You can see here the 3D printed part is now surrounded by a simple bottle area which acts as a shield for it, with a door which is stapled in place. The top part is vacuum formed and will eventually be screwed in place, although I don't have the appropriate screw holes lined up at the moment. This will fit on top of this part here, which adapts to the rocket, and will simply sit on there and also screw in place. This part will then be taped or screwed into the rocket. The parachute deployment mechanism is painted in bright colours with this fluorescent orange ring in order to see it in the sky so it doesn't get lost. It will also have a bright red parachute to ensure that we can still track the rocket and don't lose it as it's coming down, even though it will reach about 200 meters in height, hopefully. So here are the two stages for the rocket. We have the first stage on the right and the second stage on the left. So this shows the rough size of them. Obviously they're not entirely complete and it's not ready to launch because the electronic systems aren't finished and some of the other parts such as the staging mechanism and camera and altimeter aren't complete, but it just shows you roughly what they'll look like and how big they'll be. Obviously they'll be stacked on top of one another. You can see here the splice joints for 3 of them, and then this one isn't glued yet because I have run out of epoxy. You can see the parachute deployment mechanism here and the staging mechanism here, and they do assemble onto one another. It's just that I don't have enough space in the house to actually do it. It's too tall. That's all for this part. I hope you enjoyed seeing some of the new sections of the rocket, and I'm currently working on a new camera which I've bought which shoots in 1080p quality, as well as a custom-made altimeter in order to record the accurate altitude of the rocket. Hopefully next time I'll have the launcher finished as well as some of the extra electronics for the rocket so that we can get it ready for launching in July. Thanks for watching.